Modern Age MCQs, Physics First Year, Unit 4, Work and Energy, Part 1. If momentum is increased by 20%, then kinetic energy increases by. The option A is 44%, option B is 55%, option C is 66%, option C is 77%. The key is 44%. Therefore, correct option is A. Reason in the momentum P is equal to mv, mass M does not change, but V changes with the change in momentum. Therefore, percentage change in momentum means percentage change in velocity, which is equal to 20%, or the ratio of change in velocity divided by initial velocity is equal to 20 divided by 100, which is equal to 0.2, or Vf minus Vi divided by Vi is equal to 0.2, or Vf divided by Vi minus 1 is equal to 0.2, or Vf divided by Vi is equal to 1 plus 0.2, or Vf divided by Vi is equal to 1.2, or Vf is equal to 1.2 times Vi. In the kinetic energy Ke is equal to 1 by 2 mv square. Mass m does not change with change in kinetic energy. Therefore, the change in kinetic energy means the change in square of the velocity, which is equal to Vf square minus Vi square divided by Vi square into 100, which is equal to 1.44 Vi square divided by Vi square, because Vf is equal to 1.2 Vi minus 1 into 100 is equal to 44%. Hence, kinetic energy increases by 44%. Two bodies with kinetic energies in the ratio of 4 to 1 are moving with same linear momentum. The ratio of their masses is option A 1 to 2, option B 1 to 1, option C 4 to 1, option D 1 to 4. The key is 1 to 4. Therefore, the correct option is D. Reason: the relation between momentum and kinetic energy K is derived as P is equal to mv, or P square is equal to m square V square, or P square is equal to 2m into 1 by 2 mv square. Here we have divided the equation by 2, and it is also multiplied by 2, or P square is equal to mk. The linear momentum of two bodies is same, therefore 1 is equal to P1 square divided by P2 square, which is equal to 2m1 k1 divided by 2m2 k2, where K1 is the kinetic energy of the first body, M1 is the mass of the first body, K2 is the kinetic energy of the second body, M2 is the mass of the second body, which can be written as M1 into 4 divided by M2 into 1, or 1 by 4 is equal to m1 divided by m2, or m1 to m2 is equal to 1 to 4. Hence, the ratio of the masses of bodies is 1 to 4. An electron revolves around the nucleus with 20 radians per second. The work done by the Coulomb's force is option A 30 joules, option B 20 joules, option C 10 joules, option D 0 joules. The key is 0 joule. Therefore, the correct option is D. Reason. The Coulomb force keeps the electron in a circle. The speed remains constant. Therefore, there is no change in its kinetic energy. Hence, the work done is 0 joule, or the work done by Coulomb's force is 0 because there is no displacement of the electron in the direction of the force. Hence, the work done by the Coulomb's force is 0 joule. Note, the Coulomb force is centripetal force acting on the electron. The work done by centripetal force is 0. A person carries 1 kg body 10 meter horizontally on a level ground. The work done by the person is option A 10 joules, option B 5 joules, option C 1 joules, option D 0 joules. The key is 0 joules. Therefore, the correct option is D. Reason. The force applied by the man is vertically upward and displacement is horizontal. Therefore, the angle between the force and displacement is theta equal to 90 degree. Therefore, the work done is W is equal to Ft cos theta, which is equal to Ft cos 90 degree, which is equal to Ft into 0, is equal to 0 joules because cos 90 degree is 0. Hence, the work done by the person is 0 joules. A lady carries 1 kg bucket of water 10 meter horizontally. The work done by the gravitational force on the bucket is option A 10 joules, option B 5 joules, option C 1 joules, option D 0 joule. The key is 0 joule. Therefore, the correct option is D. Reason. The gravitational force acts vertically downward and displacement is horizontal. Therefore, the angle between the force and displacement is theta is equal to 90 degree. Therefore, the work done is W FD cos theta is equal to mg into d cos 90 degree, which is equal to mg into d into 0 because cos 90 degree is 0, or W is equal to 0 joule. Hence, the work done by the gravitational force on the bucket is 0. A boy pushed a block of 10 kg through 10 meter along an incline of 30-degree inclination. The work done by the gravitational force on the block is option A plus 980 joules, option B plus 490 joules, option C minus 490 joules, option D minus 980 joules. The key is minus 490 joules. Therefore, the correct option is C. Reason. The component of the gravitational force along the incline is Fg is equal to mg sine theta. Fg is equal to 10 into 9.8 into sine 30, which is equal to 10 into 9.8 into 0.5, because sine 30 is equal to 0.5, which is equal to 490 Newton. The angle between Fg and displacement is theta is equal to 180 degree. Therefore, the work done is W is equal to Fg d cos theta, which is equal to 49 into 10 into cos 180, which is equal to 49 into 10 into minus 1, because cos 180 is equal to minus 1, which is equal to minus 490 joules. Hence, the work done by the gravitational force on the block is minus 490 joules. Someone pushed a block of 10 kg through 10-meter long an incline of 30-degree inclination. The work done by him on the block is option A plus 980 joules, option B plus 490 joules, option C minus 490 joules, option D minus 980 joules. The key is plus 490 joules. Therefore, the correct option is B. Reason. The component of the gravitational force along the incline is Fg is equal to mg sine theta, which is equal to 10 into 9.8 into sine 30, which is equal to 90 Newton. The pushing force upward along the incline is F is equal to Fg, which is equal to 49 Newton. The angle between F and displacement is theta is equal to 0 because the displacement is in the direction of the force. Therefore, the work done is W is equal to Ft cos theta is equal to 49 into 10 into cos 0, which is equal to 49 into 10 into 1 because cos 0 is 1, or work done is equal to plus 490 joules. Hence, the work done by someone on the block is plus 490 joules. The escape velocity of 0.25 kg body from Earth's gravitational field will be option A 9.8 kilometers per second, option B 11 kilometers per second, option C 0.5 kilometer per second, option D 30 kilometers per second. The key is 11 kilometers per second. Therefore, the correct option is B. Reason. The escape velocity formula is V escape is equal to 2GRE square root, shows that it is independent of the mass of the body. Therefore, the escape velocity is equal to 2GRE square root, where RE is the radius of the earth, which is equal to 2 into 9.8 into 6.4 into 10 power 6 square root. In this case, 6.4 into 10 power 6 meter is the radius of the earth. Simplification gives the escape velocity is equal to 11.2 into 10 power 3 meters per second, which can be written as 11.2 kilometers per second, or nearly 11 kilometers per second. Hence, the escape velocity of 0.25 kg body from Earth is 11 kilometers per second. Which one of the following fields is non-conservative? Option A, gravitational, option B, electric, option C, magnetic, option D, resistive. The key is resistive. Therefore, the correct option is D. Reason. A field is conservative if the work done by the field on a body is independent of the path followed by the body between two positions, or the work done along a closed path is zero. In the resistive field, the conditions for a conservative field are not satisfied because of the dissipation of energy. Hence, the resistive field is non-conservative. The dot product of force and velocity is called option A, couple, option B, momentum, option C, power, option D, impulse. The key is power. Therefore, the correct option is C. Reason. The power is defined as the rate of doing work. Therefore, Mathematically, the power is P is equal to work divided by time, which is equal to F dot D, where F dot D is the work, divided by T. T is the time, R. P is equal to F dot D divided by T. It is the definition of the velocity. Therefore, we can write the power P is equal to F vector dot V vector. Hence, the dot product of force and velocity is the power.